Instagram.
Your voice is breaking. Wait a minute. Your voice is breaking. No, your voice is breaking. Just see my. One second.
To start. Okay. Are we going to start now? Hello?
Yes, we are going to start it now. My microphone is not working. Just a minute.
Okay. Okay. Got it.
Just a minute. Am I audible connect clearly?
Yes, you are. You are audible.
Any difficulty you have in the previous chapters?
What did we learn? We learned about normal model,
Correct.
the Z-score,
Correct.
the bar graphs, dot
Correct.
plots, IQR,
Correct.
histograms,
Correct.
and pie, yeah, pie charts,
I shall yes.
frequency tables, relative frequency tables,
Correct. Then
qualitative categorical
standardization.
variables,
Correct.
discrete and continuous variables.
Mashallah.
Am I missing anything?
No, no. You the standardization. The most important is standardization.
Oh yes,
Correct.
standard deviation, yeah, which
Standardization
is
of variables.
which is characterized by samples and population.
Very good. Good. Good questions. I like your dedication. We will start our class. It's I think class number 80.
Mm-hmm.
Yes. So, okay.
Okay, so we're ready?
Yes.
Yeah, okay.
Unit 2 we have started. Okay, come on. Come on. So
Mm-hmm.
what we are going to see in Unit 2 is quite interesting because we are going to learn new things here. Unit 2. Okay, so what's the topic? What's the heading of Unit 2 is exploring, exploring two variable data. Two variable data. Two,
Mm-hmm.
two variable data. Two variable data. Okay. So now what we were seeing in the course in till now that we are exploring the quality or quantitative characteristics. Qualitative or quantitative characteristics of the variable which was assigned to the x-axis. Likewise, if it was inches, then we used to plot a dot plot. If it was a categorical variable, then we need to plot the bar chart. If it was a continuous variable, then we need to plot the histogram. Different things we were seeing. But now what we are doing now, we are seeing relationship between two variables. Okay. Whenever there are
Mm-hmm.
two variables, either it be whenever there are two variables, either it be quantitative or categorical categorical, when they are related in a column, when they are related in a column, related in a column, we generally see, we generally See the relationship. See the relationship. Now, what does relationship means and all? We'll see it further. Okay. So, what task he has given here? That see the introduction in which what we see different things. I'll leave it as we have started the topic. Okay. So, introduction, we have given a thing that measuring the size of our hand, measuring the size of our hand, and seeing
Mhm.
that how many candies fits in our hand. You have examined it when a small baby he puts his hand inside a jar and takes out the toffees or chocolates from it. You will see that he will take around 4 to 5 chocolates. Yes, one was it.
Yeah.
And in comparison to us, if we put our hand, we are older and very older than them. And if we put our hand in that jar, we will exponentially take out many toffees. Yes or no? For example, we are comparing uh, toffees, toffees taken out, and here are the what we will basically say age of the children. For example, the age is 5, so the toffees will be 5. For example, the age is 10, then the toffees will be 15. For example, as the age grows, the size of the hand also increases. Yes. So what he's generally doing, he's not seeing the age. He's generally seeing the size of the hand. He's measuring the size of the hand. For suppose it is 5 centimeter, then for 5 toffees fit in it. For suppose it's 10 centimeter, 15 toffees or chocolates fit in it. If it is 20 centimeter, very large hand, then for example 39 toffees will fit in. So what you can see, as the size of the hand is increasing, the number of chocolates in hand is also increasing. Yes or no?
Mhm.
Yes. So this is the relationship. So I can say that if I give this column, is this variable as x, this is a variable, and this variable as y. What can I say? As x increases, y also increases. Yes or no?
Mhm. Yeah.
Increase in x, increase in x implies increase in y. So this is what we are
Why?
generally going to see the in between two variable two variable comparison. Okay, so this relationship, this relationship two variables, two variables is known as is known as correlation. The word itself suggests relation means the relation between correlation, the relation between the variables, and core means we are comparing the two variables with each other. Okay, so that's correlation.
Mhm.
Did you get that right? Or I'm trying to
Yeah.
understand. Yes, see,
Yeah.
hand
I
span in
understood that.
centimeter and number of candies. How we has taken the two columns. We can draw the two columns like this also. Hand span, for example, what he has done, hand span, okay, in centimeter, and number of chocolates.
Mhm.
So, for example, as 5, it will be 5. 10, it will be, for example, 25. And if it's 15 centimeter, it will be, for example, 50. Okay, so I've drawn a sample data here. Okay, so we can conclude that x is increasing, y is also increasing. Next. So,
Mhm.
what I have defined what is correlation? Okay, scatter plots and correlation. Scatter plots for for seeing for saying whether there is correlation. I have told you what is correlation. Means seeing correlation means seeing the relationship. I write this in brackets, seeing the relationship between two variables, between two variables, we between two variables means for seeing whether there is correlation means seeing the relationship. Correlation means what? Relationship between two variables. We generally
Mhm.
we generally plot scatter plot. We generally plot a graph, a chart or a graph, a chart or graph known as known
Let's
as
get
scatter plot. What is a scatter plot? I'll show you. Scatter plot. What do we do in scatter plot? For example, this is my y-axis and this is my x-axis. Okay,
Got scattered around.
correct. So this is the x-axis. Okay. We need to put. Okay. Now what he has done, he has explained it directly, or he has. Okay. Okay. He has given the explanatory variable and response variable. So we'll come to it first. We'll see how to do. So what I'll do, I'll take hand span here. Okay. Hand span here. Okay. And my number of candies here. Okay, number of candies here. Okay. For example, zero hand span, zero candies, 5, 10, and 15. Three values as we have taken. Okay, I'll include 20 also. Three values as we have taken. Here 5, 10, 15, 20, 25, 30, 35, 40, 45, for example, and it's 50 here. Okay, so 50. So what we'll do, see here, for 5 years size, for 5 centimeter hand, it will be 5 talkies. For 10 centimeter hand, for
Mm-hmm.
example, it will be 20 talkies. For 15 centimeter, it will be, for example, 30. And for 20 centimeters, all it will be 60. So what you can see, that the line is increasing. Yes or no? This is a curve of a line
Yes.
that is in this sense, increasing sense. Yes or no? So we can say
Yeah.
that there is an increasing relationship. And what this increasing relationship is known as?
Increasing
This is known
relationship, that
as
means it will be a positive line.
positive correlation.
Positive yeah,
Good.
positive
But
correlation, yeah.
question comes here that if I put this number of candies on the x-axis and the hands-on span on the y-axis, so will it be the same? Yes, it will be the same. But we cannot do this. But we are not allowed. We can do this, but we are not allowed to do this. Why? Because they are allowed to do this. Because I'll write it down here. Because when we are studying the variable two variable relation, then then the variables are classified into three types. Then the variables variables are classified into two types. There means when we are seeing a relationship. For example, now when we were seeing the relationship in hand span and number of candies, so these are the two variables. So there are two names for these variables. So what are those names? So one is the explanatory and one is the response. One is the
What is the
explanatory,
response?
one is the response. Okay. We can also give it as, first we'll read the definition and then what is an explanatory variable. In candy grab activity, the number of candies is the response variable. Hand span is the
Hmm?
explanatory variable because we anticipate that knowing a student's hand span will help us predict the number of candies. So what is the explanatory
Explanatory
variable?
helps
This is the
predicts
explanatory.
and a response helps tell the outcome, summarizes
Correct.
the outcome.
Correct. So the response variable is the number of candies. Number of
Mm-hmm.
number of candies.
Candies.
I can give one more simple example for these variable names. An explanatory variable is the hand span. Why is it is this? Because hand span is our, what you can say. There are two words for it. We can write it as
Wait,
dependent variable. No, this will not be dependent. No? Hand span equals to
its
number of
axis will be the
number of no wait.
its a,
Number of candies. Wait just a minute. Uh, this number of candies. No? Number of candies depends on hand span. Okay, na? Number of candies, hand
Mhm.
span will increase. So a hand span is independent variable,
independent, and
independent. Okay,
the number of
and this
candies
is
is
dependent.
dependent.
Dependent. Why? Well, this is more
Be,
simpler than explanatory and response. I can give. See, explanatory variable. What does it generally tell us? Explanatory variable is that we put
helps
when
us
we get
predict
a
the
response.
outcome.
Correct. When we to suspect or to predict the outcome, we need the explanatory variable. But if I told you that number of candies is 10, We cannot predict that what is the hand span. Yes or no?
Mm-hmm.
Yes. So if hands, we know the hand span, we can predict number of candies. So this is independent, and this one number of candies is dependent. Understood? We can classify. Okay.
Mm-hmm.
So what does happen that the independent variable is on the x-axis. X-axis is for the independent variable. Independent variable is also known as explanatory
Unitary
variable.
variable.
Okay, and
Yeah.
y-axis is for the dependent variable, which is dependent on x. Dependent variable, which is dependent on x for its output, also known as response. Response variable. We learn an equation. You can remember this from this also. Y equals to mx plus c. This is an equation of a line. In this x is independent because the value of x will decide, because independent variable. I'll just giving this equation because you will remember things better. Because the value of x decides the value of y. Decides the value of y. Yes or no, Zaid? Yes. So this x will be an independent variable. This x will be an independent variable, and independent variable are generally those variables which does not depend on any other thing. Okay, did you got that?
Wait, can you yeah, yeah, I got that. Can you give me 1 minute?
Yes, sure.
Yeah, back. Back.
Okay, that's good. So this the on the x-axis, every time independent variable comes, and the second name for independent variable, the name is explanatory variable, and the second one is the response variable. When we enter the value of the explanatory variable, we get the response. Is it clear, right?
Yeah.
Okay. Okay. So this is clear from it, and so now we'll go on to it. Okay. Okay. Now I've told you, I'll explain you once the correlation also. So correlation, then we'll go on to the sums. I'll finish one topic. Now, I've shown you how to plot the scatter plots. Did you got that? The scatter plots?
Right. You just plot
Yes.
each of the
Correct. For the
plots and
specific
just see
values
where the
on
line
the
is.
x-axis, for the specific value on the x-axis, we have to plot that point on the y-axis, looking for the value on the y-axis. That's the scatter plot. Then it will look something. Okay. So there are three types of correlation. Basically, that's the positive one, no correlation, no correlation, positive correlation, and negative correlation. We'll see it with an example of scatter plot, so it will be more clear. Scatter plot, as well as we'll see different terminologies for it. Okay. So what is positive correlation? I'll give an example. As x increases, means as exploratory variable increases, as explanatory variable increases, the response variable, the variable response variable also increases. Understood? This is called as,
Right, that's positive correlation.
that's
Negative
positive correlation.
correl. Mm-hmm. No correlation is when there is no certain. It's not
Okay.
even a
So for
line,
example,
basically.
likewise, we have a line with increasing order. Okay. We have plots that are in the form of increasing
Mm-hmm.
sets. Okay. This is known as positive correlation.
Mm-hmm.
Okay. Okay. Well, or suppose a line is being can be drawn, a straight line with positive slope. A straight line with positive slope can be drawn is called as a positive relation. No, then I'll come to negative correlation first of all. So as the x increases, then the other variable, that's y, decreases. Means as explanatory, or we can say it as, or also we can say it as x decreases, the other will increase. Means inverse relation. Inverse relation. As explanatory variable, I'll write one sentence only. Increases. I'll not said about decrease. Increases. Then the response variable decreases. This is known as negative
Mhm.
correlation. This is known as negative correlation. And how's the graph for it? It will be
Then it will be
see here. You
negative.
see here for lower value here, the lower plots were here, correct? And for higher value here, the
Mm-hmm.
plots have rise higher. But what is the case here? I'll mark a circle here. So it will be for this, and for this, the values have gone higher. There is a positive value, but for lower relationship here, there is a higher values here. Okay, and for
Mm-hmm.
higher x on
It will
this,
be
I'll plot
lower in
across.
the. Mm-hmm.
So there is a lower on x. Yes or no? You can see this.
Yes.
That's the thing. So this is known as negative correlation. Negative
Mm-hmm.
correlation. Okay.
Correlation.
And there is the third type that's in the middle of both. That's called as no correlation. What does no correlation mean? As
There's
x
no
increases, y does not have any
there's
effect.
no pattern.
Yes, as
Yeah. So just
exploratory,
basically a straight line.
yes, exploratory variable increases, there is no change in response variable.
Mm-hmm.
That is called as a no correlation. So how does it look? There will be no pattern. See, we are seeing a pattern of a increasing line or a decreasing line here, no? Decreasing line, see, decreasing line. This is a decreasing line. But here there will be no pattern. You cannot draw a pattern here because there are both the
At
points.
all. It just
For small value, there are
it's
small
just
value
random scatter.
as well as for small values there are greater values as well. And for greater values, there are small values as well. Okay, here and
Yeah,
greater values
it
as well.
just random scatter.
Yes, randomly scattered. Randomly scattered. Correct. Yes, that's correlation. Okay, I have explained you the correlation. Now we'll look on to the sum. Just a minute, I'll drink water this time.
Mm-hmm. I'll give you a minute.
Thanks for waiting. I'm back. Okay. So now
Yeah.
here you have given the task that identify the explanatory variable. That's the I'll copy it, and we'll
Mm-hmm.
see more examples for this. Okay.
Mm-hmm.
So what we have to do? Identify the explanatory variable. That's the independent variable, and the response variable. That's the dependent variable. Yes, am I correct or am I wrong? Have I written?
Mm-hmm. Yeah, you're right.
Independent is explanatory, and dependent is the response variable. Yes. Okay. So variable for the following relationships, if possible, explain your reasoning. The weight in carats and the price in dollars for a sample of diamonds. For example, there is $1. Okay, its weight is, for example, 10 grams. So, for example, its rate will be 1 crore, 1 crore. Okay, or you can say, oh, I'll write in dollars. Not a problem. Okay, it's, for example, its rate be $1 million. $1 million. Okay. For example, the second diamond that is of 20 grams or 20 carats. So what it will be rate? Its rate will increase or decrease?
Mm-hmm.
The rate will increase, correct? If its gram weight is increased,
Yes.
then here it's 1 million, $1 million,
Uh,
and here it's $2 million. Okay. So can you
will be
tell
doubled.
me which is the
Yes.
explanatory variable and what is the response variable?
The explanatory variable is the weight.
Is the weight. Yes. Explanatory variable is the weight. Correct. So it's explanatory. Correct. And then the left one, that the price is the response.
Is the
Why?
price.
Because, yes, because the price
Yeah.
of the diamond is dependent upon the weight and the carat of it. Yes or no? So this is dependent. The price is
Mm-hmm.
dependent. So this is response and this is explanatory. You got that right?
Yeah.
Yeah. The SAT math score and the SAT evidence based reading and writing score for a sample of data. So, for example, there is a SAT exam and the SAT score of students in maths and SAT score of students in evidence based reading and writing score are seen. That is, if he has scored 20 marks in maths, he can score either 15 or 10, not a problem. It's based on his skills in writing and listening. Yes or no? So he can score 20 also.
Mm-hmm.
Either he score in maths, he's 30. So he can score 10 also. And if he's scoring in maths, for example, 10, he can score here 30 also.
There's
Not a
no
problem.
correlation.
So there will be no correlation because
I don't think there's
this
any cor
yes, because there is no relation that who will do maths better, will do writing skill also better. It is not fixed. It can be one who is doing maths better, cannot do writing skills better. One who is doing writing skills better will not do maths better. That's not fixed. And one will be the child who cannot do both of the things better. So there will be no correlation. Okay. So now I am giving you more examples. You have to differentiate between explanatory and response variable. Look, I will give you 3 to 4 examples. For example. Okay.
Mm-hmm.
We have this in one example, horsepower of car and its mileage. Okay. Then next
Mm-hmm.
is the weather weather and sale of ice cream. Sale of ice cream. Okay. Then I can give you. Mm, you can take yeah. We can take a price of house houses and location. Correct.
Mm-hmm.
Then we can take what you can say, huh, uh, price of car and you can say manufacturer. Come on, tell me. And one more I'll give you. One more I'll give you. Mm, more can I give you? What more can I give you? I wanted a. Mm, mm. Okay, come on, chalo. You start predicting what will be for the first, what it will be. And also predict it is positive or negative. It is positive correlation or negative correlation. Come on. Do the all four ones. I'll think of a fifth one also. Do it and you have to answer fast.
Okay.
Okay. Do it in your book.
Mm-hmm.
And when I'll ask, you tell me. Okay. I'm just thinking of a fifth variable. Then I will Google it.
already got the answer.
Just a minute. Okay, I can say number of hours slept and concentration in class. Concentration in the morning lecture. In the morning lecture. Okay, it can be one example. Okay, come on. Tell me in
Okay,
the first case.
I already got number one.
Okay, tell me.
The mileage is the horsepower car is the independent variable, and the mileage is the dependent variable.
Correct. So independent variable is also known as exploratory, and the dependent variable is response. You can tell me in independent and
Mm-hmm.
dependent form. No problem. Next, what is independent and what is dependent?
Whether it's whether it's exponentially and sales of ice cream is response.
Very good. Next, for example, this will be positive relationship or
Will
negative. You have to tell me the relationship also. First one, it will be
it'll be
positive or negative.
positive.
This first
Act-
one,
Uh,
horsepower will increase.
act- uh, uh,
What will be the mileage goal?
and
It will go
mileage.
down
Oh
or up?
wait, mileage will decrease, so it will be a negative correlation.
Yes, negative correlation.
Yeah,
NC, I'm writing it. Next,
not
next.
much. Negative too.
Next is also
If
negative.
technically,
Weather goes up in
I mean,
summer.
like if the weather. Oh yeah, if the weather goes up, then the excess ice cream goes up. So therefore, it's a positive correlation.
Yes, yes, yes. Correct. Next.
The not the location explanatory and price of
Very good.
houses is response,
Very good. So
and
as
this
location will
will
be
be
more standard, as location will be more standard and more what you say posh, the prices of horse will go up or
yeah.
down.
Well,
Up. Yes or no? So it is positive or negative.
positive.
Next.
Price of I don't know what that is. Car.
Price
Oh,
of car.
price of
Price
car
of car. Yes. Correct. Price of car.
and manufacturer year.
Yes. Very good.
It will probably decrease.
No. No. There is
Decrease
no relation with
the
price.
price.
Then there is no relationship and price of car and manufacturer. Whether, for example, it can be an inflation, but here, what I want to tell you that a car which is manufactured in 2009 and a car which is manufactured in 2009 and 10. So will there be any decrease or increase in the price of the car? No. Yes or no?
No, not really. Yeah.
There can be, if there is inflation, But for general, we are seeing that we can say either if for manufacturer year we can take the month it's manufactured. It's in month which month. Okay, so there will be no relation. No relationship. Okay.
Mm-hmm.
Next. Next.
All right. Next, the numbers of hours slept and the concentration in the morning. So
Yes.
yes,
This
the
is
numbers of
exploratory.
hours it's independent,
Correct.
and then the other one is response.
So is it increase or decrease?
It will just increase positive
No.
correlation.
Positive correlation it will be number of hours. Yes, correct. Positive correlation. Sorry, I was wrong. Sorry. Good, good, good. Good, Zaid. Good.
Yeah. Yeah. Okay.
Okay. So we have Alhamdulillah explored what is exploratory and what is response variable and also seen positive correlation, negative correlation, and no correlation. Yes or no, Zaid? Yeah, that's good.
Mm-hmm.
Okay, as now we come on to the scatter plot displaying relationship. We have seen, but just for revision purpose and for just for thing, a scatter plot shows the relation between two quantitative variables. So when is a scatter plot used? You can write this. When we are, I told you, when we are seeing the relationship between two variables, then scatter plot is generally used. Okay. So measured on the same
Mhm.
individual, the values of one variable appear on the horizontal axis and the value of the other variable appear on the vertical axis. Each individual in the data set appears as a point in the graph. So each individual must be seen as a point on the graph. That's the thing. Okay. So how to make a scatter plot? It has given a label the axis, put the name of the exploratory variable under the horizontal axis. We have seen independent variable is also on the is always on the x-axis, and the dependent variable, that is the response variable, is on the vertical axis. That's the y-axis. If there is no exploratory
Mhm.
variable, either variable can go on the horizontal axis. Matlab, if there is no independent variable, if there is no relationship, for example, there is no relationship. There is no relationship, for example. Relationship in some, for suppose column 1 and column 2 we are comparing. So either you give column 1 here or column 2, or you do like this, column 2 and column 1. Doesn't matter when there is no relationship. Did you got that? Yes. So
Mhm.
scale the axis, place equally spaced tick marks along the each axis, and the axis should be scaled. Scaling of axis is scaling of axis equally spaced means if I am taking a 5 year, so it will be must 5. If I am taking 10 years, so this must be, for example, equally scaled here. Okay. Okay. So scaling of the axis is there,
Mhm.
and plot individual data values, and then we can join the data line, or just joining is not there in scatter plot. Just we plot the plots and leave it, and from the plots you can see whether there is positive relationship or negative. We generally don't draw a line in the graph in the scatter plot. This must be clear. Okay.
Mhm.
Come on. So this is a data about the basketball franchises or basketball clubs, and they pay the players for playing for their club or playing for their team. So does the payment to the players, does the payment amount of payments to the players affect the performance in their match in a match. So if we look at into this, you can say, you can generally say no. The payment of the players to the players will not affect the performance in the match. Yes or no, say? But we cannot conclude. But we cannot conclude without evidence. But we cannot conclude things without evidence. Yes or no?
Yeah.
Yeah. So we cannot conclude things without evidence. So we need. So for reasoning, we need data. We need data. So he has given data there. Okay.
Yeah.
Here is the data. Okay. So we have to, what we have to do? We have to plot this data to see how he has plotted. So can you see some relationship there?
There is a positive correlation.
Yes, there is a positive, but there are two types of positive correlation. Two types means we can say positive correlation in two types: positive correlation and or negative is also there. Same thing lies for negative also. Positive correlation, strongly positive, three generally we said: strongly positive, moderately positive,
Moderate.
or weakly positive. Or
Moderately
yes,
positive
moderately,
correlation.
weakly positive. So what it is? Moderately positive. Yes. So this yeah.
Moderate.
Okay, understood, right? Yes. So
Yeah,
now he is describing a
understood.
scatter plot. See here. He has now, we have seen and I have taught you all this further only in the starting of the lecture. Yes or no? Yeah. So he is telling when there is
Yes.
a data point in an increasing order, here it is a positive correlation. Here he has stated it. Okay, positive association or positive correlation. Association, the word is used here because when correlation will be defined further in the book, he will come with positive and negative correlation. Just you can use the word association also. Association means when relation is Seen? Relation is seen. Relation is seen. Then association, the word start. Association. Okay, you can use the word association. No problem. Okay,
Mm-hmm.
so there is, and if there is no association, means no pattern is found in the data, then there is no association. And good example he has given: height with amount of sleep. Does this affect height and amount of sleep? No. A
No,
man
because there's no
whose height is
correlation.
185 centimeter, he can sleep for 10 hours as well as he can sleep for 6 hours as well. There are different kind of men who have a different. Okay, now there is positive, negative association, and no association. Now we have seen that two
Mm-hmm.
variables have a positive association when values of one variable tend to increase as the values of other variable increases. Okay, what is two variables having a negative
Mm-hmm.
association? I have just explained you. I just copy it on the board. The whole thing I will copy. Okay. So he is telling here, as one variable x increases, so y also increases. Here he's saying that x increases, y will decrease. And for there is no association between two variables, knowing that the value of one variable does not help to predict the value of other variables. So as x increases, no change in y is noted. Okay, so that will be the case. Is it clear that things are clear?
Yeah.
So how to
Yeah.
describe a scatter plot? So he has given a scatter plot can be shown as a positive. There are three types how we can describe: positive, negative, and no. So form, if it is a linear, and a non-linear form. Linear means a straight line. Linear means a straight line, a perfect straight line, and non-linear can be a curve. Can be a curve. This is an increasing curve. This is an increasing curve. And how is that
Mm-hmm.
decreasing? This can be an increasing curve. Like this can be an increasing curve. Increasing curve can be like this, but there is a decreasing curve also. When curves are there, then it is called as non-linear. Negative, this can be a negative one. This can be a negative one. This can be a negative one. So depending on the curves, it is linear and non-linear. Okay.
Mm-hmm.
And the strength
Yeah.
also strongly associated, weakly associated, or moderately associated. He has given here two things only. See, an association is strong if the points don't deviate much as from the identified, and an association is weak if the point deviate quite a bit from the form identified. Okay. And unusual features: look for individual points that fall outside the overall pattern and distinct cluster of points. Means there can be some points. Here also comes the thing of outliers, how outliers were affecting our was affecting our mean, and what you may say our mean, and the different things mean our standard deviation also they were affecting these two things. Outlier also affect the correlation of the data, the correlation, or you may say the association of the two variables. Okay, that's good. That's it. So next,
Mm-hmm.
come on, read this question, and you can give me the answer. It's very easy, sir. Come, that's
Mm-hmm.
easy
Yeah.
for you now. Come.
Mm. For the first one, there's a strong positive correlation,
Yes, correct.
and then for the last one is a strong negative correlation.
Very good. That's good. Is it the first one is linear or non-linear? See, the straight line is
Linear,
coming. Correct. And the second one is a curve. Yes or no? The curve will come.
non-linear. Yeah.
Correct. Yes. That's good. Moderately strong and negative non-linear relationship between average income and fertility rate in these countries. Okay. So there is a strong
Yeah.
positive linear relationship. See, this I have to explain you all the things. Alhamdulillah. So, now this question, come on, do this question also fast. Come on.
The explanatory variables are the amount of. Hmm.
See, this variable has nothing to be do with relation. Yes or no? This is a
Yeah,
variable
it
which is
doesn't have.
either not that does not affect. So we will leave this variable name. Yes or no?
Yeah, we don't
If there
need
is
the
no
name.
affection, if there is no affecting of the variable on to the values of the other column, so we leave that column or the variable. Okay. So in sugar and
Okay,
calories, which is
let's.
exploratory.
I guess the sugar is the exponential variable and the calories is the dependent variable.
Correct, correct, correct. Very good, very good. So make a scatter plot to display the calories in movie theater candy. You can do that and describe the relationship for me. Can you think what will be the relationship between it, sugar and calories? As
The
sugar in our
sugar,
sugar increases, the
as
calorie
sugar
increases or not?
increases, yeah, it increases.
Correct. So it will be
So it's a
positive or
positive
negative.
correlation.
Very good. Strongly
Positive.
positive or moderately positive?
Guess it's strong. I
Yes,
mean, it's
yes, yes.
moderate.
You can say. Yes, yes.
Strong.
Okay.
Strong.
Yes,
Okay.
correct. So see, this is how you can do it in your OS operating system. Okay. Stat plot. The command is stat plot. Okay. You can see it here and practice
Mm-hmm.
it on your software as well. Okay. Now there is measure linear
Mm-hmm.
association. So measuring off. I'll write down the definition of it once more. My connection is messed up. What is correlation? Correlation. Measuring of the what it is? Measuring of linear association. Measuring of linear association between variables is known as correlation. Okay, I've given you the definition. Now next is then okay. Then when we write correlation, a scale comes correlation. A scale comes. The scale is between -1 to +1. So we have seen three types of correlation. Okay, so it was positive correlation, no correlation, and I write here no. Yeah, no correlation and negative correlation.
A
Yes
negative
or no?
correlation. Yeah.
If there is a positive correlation, then the value of correlation
Mm-hmm.
must be +1. Between 0 to +1, 0 to +1. Why am I saying 0 to +1? I'll come on to that point. Between 0 to +1, if there is no correlation, the value of the it must be exactly 0. And there is negative correlation, must be -0 to -1. Because there are two types of positive correlation. One is strong and one is, for example, weak. Okay. So when there is strong, it will be very close to,
Mm-hmm.
very, very close to,
Yeah. Close to
close
each
to
other.
+1, very close to +1. When you take out the
Each
value of
other.
the correlation, each other not, very close to +1. When you will take out the correlation factor of the two columns, there is a formula there. So correlation will be very close. Likewise, it can be 0.9, 0.98. So it is very close to 1. So there is strong positive
Mm-hmm.
correlation. And when there is weak positive correlation, it is, for example, 0.123. So it is near about approximately equal
Mm-hmm.
to 0. So there is a weak correlation. But if it is exactly 0, then we say no correlation. And if it is what you say -0.987, so it is strong negative correlation, correct? And if it is far away from -1, that's -0.135, so it is weak negative correlation. Did you get that?
Mm-hmm.
Yes. Okay. So this was the thing, this was the scale, and correlation is generally denoted by the symbol for correlation is small r, small r. Okay.
Mm-hmm.
So this was the all the things. Okay. So you can name it here. See the correlation he has given here in the first diagram. The correlation is 0. So there is no correlation in the data. In the second, it is -0.23. So there is weak negative correlation. In the third, it's zero point 0.5. So it is moderate positive correlation. In the third, fourth, it is -0.7. So it is, there is, you can say, uh, what you can say. There is a moderate negative correlation. It is 0.9 in the fifth one, strong positive correlation, and minus 0.99, very strong negative correlation. Is it clear, right? Is it
Yes.
clear? Yes. So this exercise you can do it on your own. This one, the above one, it's very interesting. Okay. So this also
Yeah.
examples you can try it. Okay. Okay. So caution about correlation will start it tomorrow. Tomorrow there will be two classes. Okay.
Yeah.
One at
Yeah. Okay.
around 8 o'clock, and the other timing I'll propagate it to you. Either it will be 3:30 p.m. Okay.
Mm-hmm.
Oh, any have you
Mm-hmm.
referred me to any one of your friends? If possible,
Uh,
if possible, then do it.
yeah, I think one of my friends, yeah, I'll try
Okay.
to.
Okay. So you can give my
But it's been
WhatsApp number.
focusing, yeah.
Okay.
Mm-hmm.
If he's interested, so you can give my WhatsApp number. Thank you very much, Zaid.
Yeah.
So, Assalamu alaikum. Take care. Okay. May Allah bless you.
Alaikum salam. Okay.
Assalamu alaikum.
Mm-hmm.
Allah Hafiz.
Okay, I
Nice
love
chat with you.
this.